Um, we're having I think this is a really good mix of lightning talks because we had a really good business overview. Okay, cool. But some of you are like, all right, that was really great. Now let's talk about some practical things. I want to see code, talk about tech. And I'm really excited to introduce James Renken. He'll tell you a little bit about himself and about his company, but I will tell you that I went to college with him. So it's really exciting hey, we went to college in the 90s. Many things seemed like a good idea at the time, right? And it's really fun that he's coming and presenting at this meetup now. So I don't know. We'll have to ask. Sammy was there too. We all went to college together. So but anyway, so give it up for James.
Thanks. Can everyone hear me okay with this mic? Not so much. If I turn it on, that might be better. Is that better?
Yes.
All right. So I'm James Renken. I work for the Linux Foundation in Ops for Let's Encrypt, which is a small, nonprofit, free SSL and TLS certificate authority. So you can and should get certificates for every host you have, every host name you have. Please encrypt all the things. We are here to help you do that. And we love automation. We have about 50 million host names currently protected by Let's Encrypt certificates. And our team size is under 15. It would be impossible for us to do that without a lot of internal automation and DevOps. I'm a grumpy old sysadmin, but I love our developers. They are actually responsive and love working with us as much as we love working with them. And we also rely on automation for your side of things. The way you get a cert from Let's Encrypt is through our API. That's it. It's entirely automated. There's no manual intervention. But for a lot of environments, that's a problem. For smaller, simpler environments like a single website, the reference client called CertBot or a bunch of other clients from the community work just fine. They make a lot of things easy. Even some pretty sophisticated integration is really easy with these clients. But if you've got a large enterprise, if you've got a complex software or ops platform, that's not so good. This is yet another layer of automation for you to wrangle. And you also are going to depend on automation if you're using Let's Encrypt for a complex or even medium-sized or large platform, because our certs are only good for 90 days. That's good for security. That's good for key rotation. But it's not so good if you're accustomed to renewing SSL certs by just an email from your certificate authority. Go ahead, you have a question?
You said you were good for 90 days, but
yeah.
30 days on the slide.
Yeah, 30 days for the authorization. So the cert is good for 90 days. But if you want to renew, when you want to renew, if it's been more than 30 days since you first got your cert, you need to get a new authorization token. So you can't just get a static token from us, put it in a static file on your website, and forget about it. There's a little bit of automation involved. So that's handled really well by all of the clients, unless your environment is one that these clients aren't adapted for, aren't anticipating the complexity you have. So you need this token for each host name, and you need a new one whenever you go to renew. So that's when automation becomes more important for you, and it's when deploying it can become a little more complicated. So we need to validate that you have control over each host name you want to cert for. And we can validate that in several ways. The simple one is HTTP. You just need to have your client or your implementation sign the token we give you with your private key, put it in this static location, and you're good. We can go make sure that token's on your host name, and we know that you control that host name. Now, this is really easy for a lot of environments, but it's really difficult for a lot of others. If you're in ops and you don't have direct control or easy indirect control over your app's routing, over your front end, this is a problem for you. So there are a few ways of dealing with this. One pretty simple way is that we will follow redirects. So if you can work with your team who's responsible for app routing or whatever you have to do to get this file on your front end, you can have them just put in a one-time redirect of anything under .well-known Acme challenge off to somewhere that ops controls, that your automation, that your client can control. We'll follow that redirect and you're fine. So even if this would be a hard thing for you to automatically update more than once, if you can get that redirect in place one time, problem solved. But this doesn't work for everyone. So we support validation over DNS. This is more likely to be under the control of your ops and infrastructure department or team. So if you can put in a text record for this particular subdomain of whatever host you want to cert for, again, problem solved. But now you need to update this as well because this authorization key rolls over every 30 days. Hopefully your DNS infrastructure has an API that you can easily integrate with. A lot of them do, a lot of cloud DNS providers do. And CertBot and other clients have already baked integration for that. That's really easy. But if they don't, or if your DNS provider doesn't have an API, then you need to consider delegating. Yeah, I own that domain name. So you can pick a DNS provider. Amazon's will do this, Google's will do this, many others will, that has an API. You can just delegate that Acme Challenge host name and host that separately from your main DNS. If you don't want to move DNS platforms just because of us, that's fine. Just delegate. But let's say you're worried about the security of your account with your DNS provider or the trustworthiness of that provider, because this means that they can issue certs for you. You can self-host this. So there is a project called Acme DNS by one of CertBot's developers, where you can throw up a tiny VM, install this program on it, and it is a little DNS server specifically made for serving out Acme challenges. And it has easy integration with several clients. So again, you can get around a lot of the problems with trying to shoehorn this into pre-existing infrastructure by just delegating to something that ops can maintain or the right sub-team can maintain that's made for this purpose. There's one last way that we'll do validations, and that's TLS SNI. This is not going to make sense for most people. It's really complicated to implement, but it can be very useful if you have control over your front-end load balancer, but nothing else. So if you don't want to do DNS for whatever reason, because DNS is hard, and you can't get your front-end web server to respond to with that static token file, you can still configure your load balancer to serve up this certificate on an incoming connection. We don't actually need an HTTP request to succeed. We just need to see this special purpose certificate served up. So this is an advanced option, but it can make a lot of sense for some people. And hopefully, by delegating or by using one of these more obscure validation options, this will let you get certificates for all the things. This is really useful for internal hosts, especially where you don't want to open port 80 or port 443 to the outside world. And we do not publish where our validations come from for security reasons. So you can't necessarily say, just open up port 80 on the whole network to Let's Encrypt, because we'll be coming from potentially multiple places. But this makes it easy to get around that restriction and get more certs in your environment and get them renewed without having to find out who's getting the validation emails. We don't do that. So I should repeat again, we're a nonprofit and we're free. We have very, very good community support at our web forum and on IRC. I'm often there. A lot of very active community members are often there. But we love corporate sponsors and we love donations. We don't offer guaranteed enterprise support, but it always helps if we're more familiar with your environment and your problems. And we would love to talk with you. I can't offer guaranteed tech support directly either, but feel free to reach out. The worst thing I can say is, I don't know. And I love questions. So thank you very much, and please encrypt all the things.
I'm very bad at turning mics on. Thank you so much, James. I feel like there's probably a million things people want to ask you. And why don't we just take a couple of questions?
Sure.
And then we're going to take a 5-minute break because people might want to grab another beer. And then we're going to hear from a Twin Cities power, a power trio of, Delta, Target, and Pivotal. So don't disappear at the break, but let's ask a few questions because I know people have questions about encrypting all the things. What do you really mean by all? Maybe we should start there and then we'll take questions from the audience. What do you really mean by all?
Anything that accepts a connection hopefully should be encrypted. Obviously, web endpoints, mail servers, practically anything that has a port. You can't easily get a certificate right now for things that just have an IP address, but why not give that IP address a host name? Please do that.
Nice. Okay, did I see it? I think I saw it. Yeah, I'm like, we have a security person back here who wants to troll you. I mean, ask questions.
So is there a recommendation for a clean way to use Let's Encrypt for internal hosts, which do not have public DNS, public IPs, or public SSL endpoints so that we can avoid using self-signed certs or an internal PKI?
The only problem there is no external DNS. DNS is definitely almost always the easiest way for almost every environment to protect internal hosts. But if you can't expose DNS to the outside world at all, that's a problem, unfortunately. There may be ways around it, and I'd want to talk a lot more detail about that. One thing to consider is running a certificate authority internally. We run Boulder. Our certificate authority software that we run is completely open source. It's written in Go. We also like to recommend CFSSL for smaller environments because Boulder is pretty complex to configure and run. But there's probably a way to make this work. Come talk to us.
All right, that is super awesome. Thank you again. Give it up for James.
Thank you.